In this series, I'll be bringing you all the latest in frontline and security high-tech that could change the future for armed forces around the world. Coming up on the show, Stryker 2 takes to the skies. The fighter pilot helmet of the future goes operational for the first time. They helped save hundreds of lives. Now frontline medics are set to benefit from the latest advances in interactive technology. And we have special access to the USS Eisenhower, the flagship carrier on the front line against the terror group that calls itself Islamic State. Now, not that long ago, a pilot's helmet was really nothing more than a protective bit of headgear, but thanks to huge advances in technology, they've become almost mini computers and will radically change cockpit aviation. One of the most advanced is the Stryker 2, produced by the UK's largest defence manufacturer, BAE Systems. The Military Tech Show has been given exclusive access to BAE's Wharton Flight Centre in Lancashire as the helmet goes operational for the first time. Jessie Aru-Phillips has more.
It's taken over 20 years to develop and tens of millions of pounds. This is a key stage in the development of the Stryker 2 helmet. For the first time, it will be plugged in and fully operational in the Typhoon. These two test pilots may have seen everything during their decades flying with the RAF, but this is no ordinary flight. The Stryker 2 is one of the most advanced helmets ever produced and could make the difference between life and death. In most military flying, a pilot looks through a heads-up display fixed in the cockpit for speed, altitude and target information. It also has a bespoke night vision camera, removing the need for night vision goggles or NVGs. And this is the most crucial moment in its history. The helmet is about to be plugged into the aircraft and tested in real-life, real-time conditions. It's never happened before.
The front seat pilot is the guy who's flying with the digital helmet today. The backseat pilot is there for help with the data gathering, help with the prompting, help to just increasing the effectiveness of our testing as we go through. It's also there for safety as well, so that while the pilot is testing, the backseat pilot is watching the overall safe conduct of the sortie. I was in the RAF for 22 years, flew fighters for 22 years, and the helmet technology that we're bringing in here completely changes the way that you operate the aircraft, completely changes your awareness of what's going on around you and gives you a lot more tactical freedom to operate the aircraft effectively. I don't have to constantly stare at a target to keep situational awareness. I can look away, I can look back and see where things are. I can see all around me with the information for not just targets but also friendly aircraft, and also have the aircraft status displayed to me the whole time.
Tornish 29, clear for takeoff, runway 25, surface wind 330 degrees, 16 knots, runway surface wet, 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 over on cable up.
The Typhoon, also helpfully made by BAE, will fly over the Irish Sea for about an hour. Joining it in the skies will be the target plane. This flight takes place during the day, and the pilot will test and evaluate the symbology projected onto the visor. So how does the Stryker 2 work? Sensors in the helmet talk to fixed sensors on the aircraft, tracking the pilot's head movement, so the Typhoon always knows exactly where the pilot is looking. Radar and other sensors track enemy aircraft even out of the pilot's view and feeds it to the brains of the plane. This is then relayed to the helmet visor in lightning fast time. And it's all connected to the aircraft's weapons. The pilot only has to point his head, not his aircraft, towards the target and engage. The US-produced high-definition camera offers night vision capability, so pilots are no longer constrained by NVGs.
Night vision goggles, a lot of weight, a lot of discomfort for pilots to operate with them for long periods. Difficult to use. Require a fair bit of training and awareness to get the most out of them.
The goggles alone can weigh around half a kilo.
You have control. I have.
So put under 9G force, their weight could increase to over 4 kilos, causing serious neck strain.
Following you through. I have control. You have.
They can also strike the glass canopy.
And off.
And their circular view, nicknamed soda straws by pilots, can also be restrictive. The first daytime flight comes into land. For now, the results of the test remain confidential. BAE has competition in this area and commercial sensitivity is fierce. And there will be many more flights during this period of testing, including at night. BAE is keen to find out how the symbology will work in combination with night vision. It's a long day for the pilot, but at around 2 kilos, the helmet is lightweight and custom fitted for comfort and balance. The inner lining is made to the exact shape of the pilot's head and finished in high-grade leather. But this isn't about luxury. Comfort equals accuracy.
Tonnage 29, clear for takeoff, runway 25, surface wind calm, over and cable up.
As the night draws in, BAE hopes the Striker 2 presents a new dawn for fighter pilots.
During recent conflicts, many injured soldiers' lives were saved by the frontline medics of MERT, the Medical Emergency Response Team. Key to their success was the high level of their training, and that's about to benefit from advances in interactive technologies. Charlotte Banks has been to meet the award-winning research team behind the project at the University of Birmingham.
This is how frontline medics are trained to retrieve casualties from the battlefield.
2 mil, and we need TXA.
Yeah, 2 mil.
Crowded into the back of a noisy Chinook helicopter, flying at speed, often under enemy fire.
Do you understand?
To simulate such hard conditions is resource intensive, time consuming and expensive.
See that? Okay. Bow, side. Abdomen descended.
But the medics must get used to working in difficult places before they do it for real. There are no shortcuts.
The solution could be found here at Birmingham University, where the Human Interface Technologies team is pioneering some advanced training techniques using the latest software, simulations, and virtual reality.
So meet Steve. He's an incredibly lifelike dummy, which is helping the team experiment with what's known as mixed reality.
Essentially how this works is we are tracking using infrared cameras a person's head as well as their hands using points on their gloves and a head tracker on a head-mounted display. And this allows us to align their real-world actions with the virtual actions. So as you can see, they move the head and the hands, and they will roughly align to the virtual world. So we've both got a virtual body here, but we've also got a real simulated body in the real world. So when they actually reach out and touch something, they do actually feel something, and they can kind of start to sort of ascertain the problems and we can overlay certain effects like here where perhaps a gunshot wound. We can now add in those effects, we can add in blood effects. We can ultimately change the entire environment. So if there's a different aircraft that's being used, or maybe it's more static ground-based triage tent, we can simulate that. The sort of possibilities of the external environment we want to simulate can essentially be endless.
This is a fully immersive training environment which would allow medics to train through a wide variety of terrains, situations and scenarios. Down the line, the virtual world casualty could suffer from any level of complex injury and react to treatment in a realistic way.
Ideally, we want the system to be able to pretty much simulate any wound, even removed limbs, that kind of blast damage, major sort of arterial bleeding, and we want people to be able to sort of acclimatise to that in this kind of very frenetic environment. So in theory, we will be able to visually simulate a whole host of different conditions. One of the critical problems is there simply isn't enough Chinooks available to allow medics to train on them all the time, and it's very difficult to give them that kind of immersive experience of flying on a Chinook while trying to make these very difficult medical decisions. So the idea is to be able to give them a cheaper, more mobile solution that will at least be able to start to introduce some of these very distracting factors.
Professor Robert Stone heads up the Birmingham team. It works closely with the Ministry of Defence, looking forward 20 years into the future.
We're currently looking at the 2035 timeframe, 2035, 2040. The big problem we have is that 6 months down the line, there will be a new piece of technology, be that a head-mounted display or a glove or even smell technology, which will come out, and we'll have to revise that, revise what we believe will be available that far ahead. So it's always a juggling act from every 6 month period forward.
This industry is moving fast. Software which cost thousands of pounds just a few years ago is now available at low cost or even for free today. Training in the virtual world could one day become a reality.
Well, that's it for part one, but join us after the break for a special report when we go on board the American aircraft carrier, the USS Eisenhower. Welcome back to the Military Tech Show, bringing you the latest in frontline and defence high tech. Now, in the fight against the terror group that calls itself Islamic State in Syria and Iraq, the United States has deployed one of its biggest war machines. The USS Dwight D. Eisenhower is a nuclear-powered aircraft carrier that is the flagship of the US Navy's Strike Group Carrier 10. And with 70 aircraft on board, it packs considerable firepower. Simon Newton was granted rare behind-the-scenes access to the carrier during its deployment in the Persian Gulf.
When you see the aircrew, wave our hands and holler, here we go, here we go, here we go. Make sure you put your feet flat on the floor.
We're about to experience just what it's like to land on an aircraft carrier. And soon out in the Arabian Gulf, she appears. On the signal, we brace and seconds later hit the deck at 100 miles an hour, coming to an abrupt halt on this huge floating airfield. The Eisenhower is one of 10 nuclear-powered Nimitz-class carriers in the US Navy. On board is a complete air wing of 7 squadrons, 66 aircraft, including 53 F-18 Hornets and Super Hornets.
The Eisenhower has 4 steam-powered catapults. Each of them is capable of sending an F-18 down this 300-foot runway, taking it from 0 to 170 miles an hour in just 2 seconds.
Getting these jets airborne and into the fight are teams of specialists, from weapons handlers to aircraft movers, each role identified by a different coloured shirt. Controlling the flow of aircraft on and off the carrier is primary flight control 10 stories up.
Get on set, 480 Rhino.
It's run by a team of air bosses, all of them former US Navy aviators. 6 different types of aircraft operate from the Eisenhower, from fast jets to helicopters. On deck, they park them in every available space, while down below, teams of engineers work around the clock, making sure as many as possible are operational.
There's 5 squadrons of F-18s on board the Eisenhower, and these cavernous hangars are where they store some of those aircraft. There's 3 of them, and the conditions down here are really hot and oppressive. Now, hundreds of people work down here during the day, conducting maintenance, everything from minor repairs to complete engine rebuilds.
We have avionics, airframes, we have structural mechanics, we have pretty much our plane captains too that are down here. We work on all the aircraft systems, from electronics all the way to the structural material on the aircraft. We do our turns down here, and we do all our major inspections down here as well.
The Ike is essentially a floating town. On board there's several gyms, 3 hairdressing salons, even a supermarket. What the Eisenhower is also guzzling is jet fuel. With so many aircraft flying so many missions, they need regular replenishment. These Nimitz-class carriers can store more than 3 million gallons, and today a US Navy tanker, the John Erickson, has pulled alongside to top up the tanks. For the crew of this huge warship, this mission means 7 months away at sea. Soon the US Navy takes delivery of an even bigger carrier, the Ford class, the steam-powered catapult replaced with a powerful electromagnet. For now, though, this remains among the world's most potent warships. The Eisenhower is a Nimitz-class carrier that's had billions of dollars spent on keeping it up to date. The last overhaul was in 2015. The flight deck is over 332 metres long and more than 76 metres wide, making that 4.5 acres of US real estate in whatever ocean they choose to put it in. It's as tall as a 24-storey building, that's around 75 metres. It has 2 nuclear reactors that give it a top speed of over 30 knots. That comes from 4 5-bladed 8-metre screws. Each of those weigh around 30 tonnes. There are also 2 rudders that also weigh nearly 30 tonnes each. Below decks, every inch is made to count, with all sorts of facilities and quarters rammed in. And some of those crew quarters are just a short distance away from the weapons that keep the Ike safe, and the radars that keep the crew aware. Back on the flight deck, there are 4 catapults to launch the planes into the air, and 4 lifts to bring them up to the flight deck. There's approximately 90 fixed and rotary wing aircraft on the Ike, and the squadrons stay very close to the flight deck. This is the home of the Sidewinders, Strike Fighter Squadron 86, which can trace its roots back to the Korean War. There's 5 F-18 squadrons aboard the Eisenhower, and it's in here that the pilots are briefed before each mission.
Sidewinders, we have pilots in the books, Event 3.
Once we get done with the brief, we will come back and then go through our pre-flight ritual of making sure that we have snacks that we need, piddle packs in case we have to use the bathroom in the jet, and then making sure we get all our required mission items, and then go get dressed. Once we get dressed, we'll head out to the flight deck, pre-flight our jet, check our weapons, make sure everything's good, and looks like they always have in the past. Just a cursory glance over. Getting the jet start up on time. Everything's on a timeline where we start up, we check in, we take off on deck, then we have to rendezvous overhead. We have to tank on timeline, so we have to meet our tankers at a specific time, go back out, do the same mission, tank, repeat, come back, and trap at the boat, day, night, good weather, bad weather.
In charge of getting these pilots airborne are teams of aircraft handlers called shooters, who guide the jets into position, ready for takeoff.
One of the things that we try to do even before we even start moving the aircraft is start getting to know the pilots, because we got to build a comfort level and we have to start trusting each other. The pilots completely trust us when we're doing the hand signals in order for us to be able to taxi those guys. And just like you saw, if you saw that last night, they get close to the edge. Sometimes there's not even a border and they'll feel like they're actually on top of the water. So you build a comfort level with those guys, and then the more we do this, the more comfortable they get, and a lot easier it gets for us to be moving them around.
To help them take off, the carrier is turned into wind. With the aircraft hooked on and the jet blast deflector raised, a catapult powered with steam from the Eisenhower's nuclear reactors shoots them off the short runway.
the last thing that goes through my mind is, I hope I checked everything, which I normally do. I double check myself. But everybody has their own checklist they go through in their mind, and for me, like I have my own, which kind of sounds like a song almost, but I do the control wipeout, aft, forward, left, right, left rudder, right rudder, free and correct, visually check, good engines, good nozzles, good hides, and then salute, and then hold on. So throttles at max, and then hands on the canopy bow. So the jet, once we take off, seeks a certain angle of attack off the front, so we can't really mess that part up. And then as soon as we take off, we make sure the throttles are up, gear up, flaps up, and then climb away from the ship.
Combat missions can be long, and each jet will normally refuel mid-air several times before they turn for home.
So after 7 hours in the air, these pilots then have to land back on the aircraft carrier. The area they're aiming for is only 50 feet long, and each of their landings is graded by their peers. The perfect spot to land, we're told, is to hook onto that third arrestor wire before they then come to a very abrupt stop.
On a grainy TV screen inside the crew room, the pilots can watch and hear their colleagues land on the deck above. Their marks are put on display for all to see on what they call the greenie board. Each dice represents a landing and how well they performed.
I might be the only one that says that I prefer a night pass over a day pass, just because there's less to look at, there's less to be distracted by. It's a straight in, you're looking for the ship the whole time, coming down the final approach course, and it's really hard to be distracted. You're looking for lineup and you're solving for glide slope really early, and that's it.
Now, the European missile manufacturer MBDA has been asked by Britain's Ministry of Defence to develop a new state-of-the-art missile for the country's future F-35B Joint Strike Fighter. It's called the Spear 3 and will involve 4 years of critical design and development. Eventually, it's hoped the weapon's precision and punch will give pilots decisive operational advantage. In an exclusive for the Military Tech Show, we've been given a walkthrough of how this next-generation missile will work.
Hi, I'm Tom from MBDA. I'm going to talk to you about the Spear weapon system. Here I have a half-scale model of the Spear system as it would be integrated onto the Joint Strike Fighter. We have a launcher and 4 missiles, and this would fit inside the bay of Joint Strike Fighter alongside the Beyond Visual Range air-to-air missile Meteor. Key aspects that you see here: missiles are held upside down, the wings are on the base, the fins are folded, it's a very tight package. This is the launcher structure, and this is the component that you saw in half scale on top of the missiles. This is carbon fibre, produced in the UK. It's very stiff, so that when you eject a weapon or a store out of the Joint Strike Fighter bay, the reaction on that launcher is minimized, so it doesn't flex, it doesn't bend, and it doesn't mean that any of the other furniture or weapons in the bay are damaged. To eject the Spear 3 missile from the Joint Strike Fighter, we use a cold gas ejection release unit. This is precision engineering, again from the UK. It's designed to eject the Spear 3 store out of the Joint Strike Fighter bay at a high velocity to ensure that the bay doors are open for the minimum length of time, and the Joint Strike Fighter can then return to its low observable configuration. This is a model of the Seeker that we are integrating onto the Spear 3. Very similar to the Brimstone Seeker that we see today being used by the RAF in ops, but this is the next generation. So it takes the high precision that you get from Brimstone today, but will deliver that same precision in a within visual range engagement to something much longer, beyond visual range, beyond the horizon. Has a semi-active laser channel, so very similar to Brimstone in that the pilot sees the target, designates it with his laser pod, and then engages the target. It also has a radar aspect, which in this case images the target, so it uses more power and more processing to allow us to start creating a picture of the target area and ensuring that we can engage the target, not anything that looks like a target, and ensuring that we don't engage any of the collateral. This is a test asset from the airframe and propulsion demonstration trials that we undertook. In effect, what we did was wanted to demonstrate that we could develop a new missile, integrate it onto a platform, and then launch it, control it, and fly it for a considerable period of time. This was our spare and was also one of our test assets that we integrated directly onto Typhoon. No seeker, no warhead, because we weren't demonstrating those aspects of the system, but we were demonstrating the ability to launch a missile, control a missile, and fly a missile under power for a considerable long period of time. This missile was used for Typhoon handling trials and also for the range workup trials to ensure that the range could hear the telemetry from the missile before we took its sister and flew it for the first time for real. This is a full-scale model of the operational missile. So now you can see there's a seeker where the blue band is where the warhead is kept. The significant differences between this and the model you see behind us primarily is that on that test asset, the fins are already open, but in the constraints of the Joint Strike Fighter bay, the missile has to have everything folded up, and this includes the fins. So when the missile is ejected from the bay, the fins open, control the missile, roll the missile, the wings open, the turbojet then starts, and the missile conducts its mission. And that is the Spear 3 weapon system.
Well, the Spear 3 has been successfully test-fired by another jet flown by the Royal Air Force. It's an aircraft that can reach Mach 2 and climb to 55,000 feet and represents the peak of British, German, Italian and Spanish technology. So, what is the Eurofighter Typhoon? It's the buzz term that has all of Silicon Valley excited, and it could one day mean transformational change for troops on the ground. Essentially, you take a virtual reality headset, those boxy goggles holding a computer-generated screen in front of your eyes, and you apply it to real-life objects, say a table, and you get what developers call mixed reality. And for award-winning academics at the University of Birmingham, it could mean soldiers will never see the battlefield in quite the same way again.
As you can see here, I've got two gloves and I've got these special markers on. Each marker has got a ball on which reflects infrared light, and we are surrounded by 12 infrared cameras, so they can pick up the different points and triangulate a position for each of these objects. So when I put on the gloves, we can track them in the virtual world. And as you can see from the headset, it's got a camera on so I can see, as well as another marker, so my head is tracked, so we can link up the virtual and real environments. And when I finally put on the headset, I can now see the mixed reality table, which is being superimposed over this rather standard table. And the way the system works is it's very much like a map, and it enables you to interact with that in a quite intuitive way. So you can just sort of pinch to zoom with your hands to move in and out. You can also use your hand at the edge of the table, which rotates the map around. And you can also, of course, move in with your head itself, because everything's fully tracked. So as you step around the table, it follows you.
It's a fully immersive virtual reality. The user can even bring up documents and mark routes and zones on the virtual world.
We've got this puck-based marker. This enables us to mark out safe and dangerous zones. Simply twisting this would enable us to select the green zone, which may indicate a safe zone, and then we can literally just paint out big sections of the map which we now believe are safe. And we can also paint out sections that may be enemy territory. Ideally, this system is a sort of fully integrated system, and any kind of data source can be visualized and from any sort of location. So whether it be a drone or a troop on the ground or satellite data, we can sort of integrate it all, and that data can be sound, videos, updated terrain data, could be social media data that's come in, and we can just bring it all into one location, and then it sort of give you that sort of full 360-degree space in which to show any data that's coming in.
One day, a system like this could be a fully portable command centre carried in a briefcase. Data from drones would instantly update the map in real time.
A research team from the University of Pittsburgh has demonstrated for the first time ever in humans the experience of touch sensation through a robotic prosthetic arm connected directly to the brain. Well, the hope is that one day it could help military amputees regain their sense of touch. The work is funded by DARPA, the Defence Advanced Research Projects Agency. The study's volunteer, Nathan, who became quadriplegic after a car accident, underwent surgery to have 2 microelectrode arrays the size of shirt buttons placed into his sensory cortex. That's the region of the brain responsible for identifying tactile sensations, such as pressure. They were then connected by wires to a robotic hand and arm fitted with tactile sensors in its fingers. As the researcher applied pressure to the robotic fingers, those physical sensations were converted into electrical signals that fed directly back into Nathan's brain. Well, through this brain-machine interface, electrical signals are delivered as precise stimulation, which his brain interprets as if his own fingers are being touched. And despite being blindfolded, Nathan identified with nearly 100% accuracy which fingers of the robotic hand were being felt.
Index, ring.
The gap between human and machine is closing. Well, that's it for part 1, but still to come, how Hollywood and the gaming industry are transforming military training, and why 300 years of research and development has led to a fiercely effective new drone. Hello again, welcome back to the Military Tech Show, where we spotlight the very latest in military technology. Now, across the military, defence budgets are often tight, which can limit the amount of real-world training on offer. But thanks to some groundbreaking advances in simulators, virtual reality and emulation, alternative teaching and practice environments can prove just as effective. Well, I went along to ITEC, the key international forum for the very latest in military simulation and training, and saw how the virtual world prepares the military for life in the real world. Simulators, emulators, call them what you want, but they're getting closer and closer to the real thing. ITEC had some of the latest on the market, and I asked the manufacturers what they can do for the military, including one that left me feeling distinctly green.
It's a robotic motion simulator platform. We placed it on a 20-foot container, so it's a mobile platform that you have. It's an industrial robot. It's the system we have here is capable to carry up to 300 kg load. We have a cockpit integrated here with an HMD, so you're in the virtual world. You can turn your head, see all the motion around, and the robot does the flight motion of the system. We use washout filters to simulate motion that you do. For example, if you accelerate, the robot moves up front, and then we tilt the cockpit a little bit, so you actually feel that the acceleration goes on, but the robot moves back. So we can make 360 rotations. We can use the whole system as a centrifuge, turn endless.
How do we put a price tag on this? How much does this bit of kit cost?
Well, for you, we make a special price. No, it's actually like the platform we have here is about a little less than 500,000 euros. And the biggest and most expensive system we did so far was 2.5 million euros.
It's a lot of money, but simply putting a fast jet in the air for an hour costs tens of thousands of pounds, so even pricey simulators can save money. There were trainers for all kinds of roles, including joint terminal attack controllers, the men who call in airstrikes, and artillery.
Within this, I have full emulation of all the training devices that I would use in real life. So I have 2 immersive radios that are accurate to what a US JTAC would use, along with a VDL feed, which is a video downlink feed, giving me a view of what the aircraft is looking at that time. On this side, I have 2 radios as well that I would be using, along with a GPS receiver to get my position and to also generate target coordinates based off of this device. This device is another emulator. It emulates 2 laser rangefinders, both within the inventory for NATO JTACs. A laser target designator giving me the ability to self-laze munitions off of aircraft on the ground, and a mil-reticle bino giving me the ability to adjust fire from the mortar based off of corrections from impacts.
What we have here is an appended mortar. It's a 60 mil mortar. It works like a real mortar. You can do your adjustments. You have your sight on it. So I can do my adjustments, right, left, up, down, going by the commands from the forward observer. It works with simulated rounds. They're smart rounds, so you have charges. Depending on how far you want the round to go, you can either add or take away charges. It also has fusing on it. This is a smoke round, so there's only 1 fuse or 2 fuses. So you can adjust that. You can drop this to mark a target. It is hooked up to air so that you get some recoil. This could be used to mark a target for the aircraft flying around. I drop it here. It shows up in the scene for the JFO or the JTAC, and the pilot on the pilot station can see it as well.
There are 2 distinct types of simulators here. There are ones that allow people to train to do things that they can do in real life if money and logistics and time were no object, but also the ones that allow people to train to do things they can't yet do in reality. And those are the ones that are helping to shape the future of military technology.
This is a simulation of the Queen Elizabeth class carrier, which isn't yet in service. And we've been able to use this simulation environment for several years now to refine things like the design of the carrier deck, the visual landing aids you see, some of the systems on the aircraft, and some of the approach manoeuvres that you're seeing being played back here. And we've been able to use the simulation environment in an engineering context for several years now, before the aircraft and the ship were even built.
So military simulation, emulation, and even formulation are all happening right now in the virtual world. A new kind of drone, based on one of nature's most deadly creatures, is set to revolutionise the way soldiers on the ground gather intelligence. Backed by the Defence Science and Technology Laboratory, a UK company called Animal Dynamics is developing the Skeeter drone. They say it will fly faster, further and for longer than soldiers' current miniature drones, because it's built on 300 million years of research and development.
So the reason we base this on dragonflies is we looked at what's out there in the real world, and dragonflies, they hunt and kill all the other insects. So they outperform all the other insects. They hunt them down in air-to-air combat. The thing with dragonflies is they've had 300 million years of R&D in the fiercest battlefield you can get, which is out in the real world, fighting air-to-air combat, where the males fight over territories where they might find females, and the females fight over territories where they can lay eggs. And a consequence of that is that as an aircraft design, as a flight design, they're fantastically over-engineered. And you can see that when you look at how good they are at catching their prey. It catches it 9 times out of 10. So we've been inspired by that to develop these flapping wing vehicles. And part of the reason for that is I've been working on insect flight at Oxford University for 20 odd years, and we cracked the insect flight problems about 10 years ago. And one of the main things we learned is that dragonflies actually are probably the pinnacle of insect flight designs. It's going to have performance that's similar to a dragonfly, and if you watch dragonflies flying, the ones we get in Britain can do maybe 45 miles an hour. They can accelerate for short periods, for a few seconds, quite a lot faster than a Formula One car. They can pull 5G acceleration for a short period. And there are other species around the world. There's one called the globe skimmer that lives either side of the Indian Ocean, and it migrates across the whole of the Indian Ocean. So they're capable of really long-range flights, long endurance and high performance, and that's why they're a good target for us to try and mimic. Compared to a conventional helicopter-like drone or quadcopter, flapping has a number of advantages. The most obvious one is compared to a helicopter. With a helicopter, you've got the blades spinning, lots of inertia and gyroscopic forces in those, which means it's slow to maneuver. But the other problem is that one of the blades is going forward. So as you're flying towards into the wind, say, one of the blades is going forwards, the other blade is going back, and that generates a roll moment, turning force. And inevitably, that's what limits the speed that they can cope with. And the speed is what limits the wind strength that they can fly in. Whereas with these, they're completely symmetric. The left side's doing the same as the right side. So there's no roll moment. It's fully stable going straight level flight. But also you can control the thing at a rate that's the same as the wing beat frequency. So you've got really high bandwidth on control. So if you get turbulence and gusts in there, you can respond instantly and keep the platform doing what you want it to do, not doing what the wind is telling it to do. So timeline on these things. Well, 5 years ago, I don't think we would have been able to produce these. So what's driving development now is that, particularly through the mobile phone industry, the electronics, the cameras, and particularly the batteries have got much better. Smaller, lighter, more powerful. And that's what's allowed us to develop them now. So the big advantage this gives the soldiers is it gives them a small surveillance drone they can carry anywhere in the field and they can use in normal operating conditions. So it might be a bit windy, a bit dusty, might even be a little bit of rain, and these things can still operate. Already people have started using these very small drones as a way of getting surveillance information in places that are difficult to reach with other vehicles. What this is going to do for the soldiers is make that something they can do every day. So we're producing them down to a cost where the soldiers can use them without worrying about having to go and find them later, and we're building them so that they can cope with any kind of conditions that you might encounter in normal operating situations. And it's carrying cameras. It can work in daylight and low light conditions, so you can fly it around a corner, over a wall, into a compound and see what's there before you have to expose yourself to what's going on, which might not be something you want to see. It's nicer to see it with this than firsthand.
And that is it from the Military Tech Show for now. We hope you've enjoyed the programme. Until next time, bye-bye.